Hello learners, welcome to Education Online program. I'm teacher Willa Lucia. So in our previous lesson, we looked at calculations on projectiles. So we had an incomplete work for the last example, and it's what we shall continue with today. And after that, we shall look at some other interesting kind of motion, which is known as the circular motion. But let's first continue with our example from the previous lesson, which was talking about a bomb. A bomb is released from a jet fighter plane moving with velocity of 400 meters per second to hit a rebel. A rebel camp. If the bomb took 10 seconds to hit the target, calculate we have to find the altitude, that is our A. We need to find the altitude at which the bomb was released. Okay. Altitude at which the bomb was released. B, we have to find the horizontal distance. The horizontal distance from the vertical point. From the vertical point of the plane, from the vertical plane of the plane to the target. We have C as the velocity. We need to calculate the velocity with which the bomb hits the target. So that is our question. What we are going to first see is that at what height is the plane? Because if the question is telling us to find the altitude, that means we want to find the height at which the plane has reached. But then, was the plane given an initial velocity? Yes. The plane was moving with a velocity of 400 meters per second. If it is 400 meters per second, was it moving in the vertical direction, or it was taking the horizontal motion? So you see that when a plane actually starts flying, it moves from the ground, assuming this is our ground. It will move from here, and then it takes a vertical position up. When it reaches the maximum height it's supposed to fly, you will see that it will attain something like this. It starts moving in a horizontal manner, meaning that the 400 meters per second given to us is the initial velocity this plane attained when it is moving in the horizontal direction. So what else have they given us? We have the time to hit a target camp. If the bomb took 10 seconds, so we have the timing for the bomb to leave the plane and then drop down. So it took the bomb 10 seconds, meaning that we have our ux, which is equals to 400 meters per second. So this ux is the initial velocity for the horizontal motion. So what if this one is this, meaning that our uy is equals to what? We know that at maximum height the velocity there becomes 0. So when this plane reaches this, when it moved like this from the surface of the earth and then reaches maximum height here to attain this motion, at this point here it is what? It is having a velocity of 0 meters per second, meaning that the uy, which is our initial velocity for the motion in the vertical direction, is equals to 0 meters per second. So now what do we have again? We have the timing, which is t. That is the time for the bomb to hit the camp. We have it as 10 seconds. So you see that our ux is equals to the initial velocity in the horizontal direction. So even our uy for it is the initial velocity, but then in the vertical. So if we have that, how do we find the altitude, the height that the plane reached? So to find this height, we are going to use the formula for motion in the vertical direction, because if you say you're going to take the horizontal, this horizontal here does not give us that altitude we want. So we are going to consider the vertical, considering the vertical motion. So in the vertical motion, how do you find this altitude? You look for the suitable equation to apply there. So this time round, we cannot use the first equation because it does not have the distance we want. So we cannot use the third equation of motion also, because in the third we've got the final velocity, which here the question hasn't given us, but we have the second equation of motion, which says that our s is equals to ut plus a half gt squared. We are having it here as a plus because the bomb has been released from a height and then it is coming back down to the earth. But then if the bomb was from the earth going upwards, we shall have it here as negative, because the acceleration, the bomb will be moving in the opposite direction to the acceleration due to gravity. So if we have like that, what do we have as value of u? Here, because we are taking the vertical motion, our u at a maximum height is equals to 0. So we shall have it as our s is equals to 0 times the 10 plus a half. We are taking acceleration due to gravity as 10 meters per second squared. So we shall have here 10. And then we have our timing, which is the 10 seconds, but squared. So we shall have our s is equals to, this is 0 plus a half times 10 times 100 squared. 100 squared is more like 10. This is 10 squared. 10 times 10. So for you to get 10 times 10, you can multiply this. 0 times 1 will give you 0. 1 times 0 will give you 0, and then 1 times 1 will give you 1. Then you add the 2 to give you 0. 0 plus 0 will give you 0, and then 0 plus 1 will give you 1. Meaning that our 10 squared is equals to 100. So if we have it there as 100, now we can reduce it by the 2. If you count, so 2 here will go once, and then 2 will divide 10 how many times? 5 times. The meaning that we have now S is equals to 5 times 100. And what is 5 times 100? You'll have it as 500 meters. Meaning that the height, that was the maximum height reached by this plane for it to release the bomb, which is more as also the altitude. So that is our answer for the first. Then let's look at the second, the horizontal distance from the vertical point of the plane to the target. So assuming, okay, assuming this is our horizontal distance here. So from this horizontal distance, the plane was given this velocity and then moved, reached a vertical, reached the maximum height. Then from there it started also, the bomb was released from there, and the bomb was to fall right here. This is, we assume here is our camp. This is the point that whatever was targeted to fall. So the question is telling us the horizontal distance from the vertical point. So we assume this is our vertical point here. If you take that vertical point, here is the maximum height. So we want this distance here. This is our horizontal distance. So how do we get this horizontal distance? Because if you check from here, this is our vertical point. I'm just trying to connect it to the axis so that it can be easily noted. So this is from this point of the vertical height up to the camp here. That is the distance we want to find, which is X. So this is the horizontal distance. How do we find it? What happens at this point? You'll see that with the horizontal, we already had the initial velocity with which the plane was moving, which is the 400 meters per second. So we shall have it as our S. Here we are considering horizontal motion. So we shall have our S is equals to UXT plus a half GT squared. But what do we know about the horizontal motion? We know that with the horizontal motion, there is no acceleration due to gravity acting on that body. So at that point, when it's taking horizontal motion, acceleration due to gravity is equals to what? To 0. So meaning that if we substitute here 0, the whole of this will be cancelled. So we shall have it as our Sx is equals to UXT. Our Sx will give us the initial velocity is 400 times the time taken for the bomb to land to reach the camp, which is 10 seconds there. We shall have our distance is equals to 400 times 10 will give us 4,000 meters. So you see, the horizontal distance from the vertical point up to where the bomb will land is 400 meters. So if we have now that our last Roman is telling us to find the velocity with which the bomb hits the target, what velocity, what speed did the bomb attain for it to come and hit the target right here? So we have to get the speed. So to find the speed, we are going to use the first equation of motion. We shall have it from, this is the B, and we have this is for A. So now see, with C we are going to consider the first equation, of motion. The first equation says that our V is equals to U plus G plus GT. So what is the velocity at the maximum height? At the maximum height, we said our velocity is equals to 0, meaning that our U here is equals to 0. We shall have our V is equals to GT, because we can say since U is equals to 0 at maximum height. So if it's like that, we shall have our V is equals to the value of G, which is 10, times the time taken for the bomb to land and reach the camp, which is also 10. So what shall we have? We shall have our V is equals to what? 100 meters per second, meaning that our bomb was moving with a speed of 100 meters per second to hit the camp. So this was our question that was incomplete in the other previous lesson. So now we have it all here. So if you were following it, you can now take it from this to the previous lesson. Now let's take a look at circular motion. What is this circular motion? From the word alone, if you look at circular, meaning that something moving in a circle. Because if you take the term circular, it is from circle, and then you know motion. So now today, let's take a look at this circular motion briefly. With circular motion, let's take a look at this example. I have this wire. I am going to swing it, and let's see what happens. So assuming this is just like a pendulum bob, let's take the top of the wire as the bob, and then our string. So I'm going to hold it right here. Let's see what happens. When I'm swinging this, you'll see that it is taking a what? A circular path. But then if it is taking a circular path, what is happening to this? To the bob, if you look at it. The bob is moving around the circumference of this string. And then the circle. Where is the center of the circle here? The center of this circle made by this wire is right here. It is this point I am actually holding. This becomes the center. So we shall have something like this. We shall have something. This is how it is moving. So this one here is where I was holding, becomes the center. And the top here, this, you know, it is the circumference of this circle. But then the bob is taking the circumference and moving in this circular point. So we can say that circular motion is a motion in which the body moves in a circle about a fixed point. So my hand, as I was holding it right here, is actually the fixed point. But you see, it is taking its motion like this. So you will see that with this circular motion, what happens is that the velocity keeps changing. The velocity does not remain constant. Not only the velocity, but also the direction the direction that the bob is actually taking keeps on changing. So we can say, if we have a circular motion as the motion is the motion which a body makes in a circular path. So let's take a look at this. If it is the circular path, we assume this is our circle. We started swinging the body right from here. We are taking this as our fixed point. What happens is that we say that with circular motion, the velocity is not constant. The velocity actually keeps on changing from one point to another. So if it is right here, what happens? If the body reaches here, you'll see that the velocity is right, moving this way. If that is our velocity, we also have, because as I am holding it is a string, meaning that we have another force acting on this string, which is known as the tensional force. And every tensional force acts towards the center. So you will see that this, if this is my rope, if it reaches at this point here, this is how our tensional force will be acting. It will be moving towards the center, and this one here is our velocity in meters per second. But then also we have the weight of this bob acting where? Acting downwards here. So you'll see that here it's going with its weight. So when it reaches here, the direction, also the velocity at that point also changes. So you'll see that the velocity here is taking another direction. You see, it is moving, the body is moving in this direction here. So our velocity will be at that point here. This is our V. What happens is that even this one, at this point, there is tensional force still acting on this wire, and this tensional force acts actually in the middle of acts towards the center, which is T, and then we have it as T. At this point here, you also find that it takes a different direction. The velocity will be moving this side. You see that? And the tension keeps acting in the center. From this rope, when it reaches this point, it takes to the center there as our T. At this point, there is also a difference. So you see that when it reaches there, there is also what is known as the weight of this body acting on it. Even at this point here, you see that the weight, there is weight also acting on it, and the tensional force still towards the center, T. So if you see this, you find that with the circular motion, it has an acceleration, because if you're swinging a body, that means that you've given it and you have accelerated it. But then in circular motion, how do we call this acceleration? Do we call it acceleration due to gravity? No. We call it the centripetal acceleration. Because if you look at centripetal, it's coming from circle, the word circle. So something taking the circular path. So the acceleration with the body moving in a circular motion is known as the centripetal acceleration. It also has a force. This force here is created by the tension that the wire has caused in this. So what is this force that is being produced here? The force we have there is what is known as the centripetal force. So there will be a centripetal force acting towards at the same direction as the tension. Because at this point here, that means that our tension is equals to the centripetal force. So there are also some other forces acting on a body describing a circular motion. So what are these forces? Let's look at that. Forces. Forces acting on a body in a circular motion. So what are these other forces that act on this body? So as you're swinging it, we know that there is tension. This tension is from this point up to the fixed point going in this direction. So if we have the tension acting on this force, on this body, what other forces do we have? We say that it also has a force that is caused by the tension, and that force is known as the centripetal force. So apart from the centripetal force, what do we have? We have another force, which is the weight. There will be a weight acting on this as it is taking this circular path. So if we talk about the tension, we say it is the force acting towards the center of the circular path. So it is this tension that provides the centripetal force. So we're going to have our first force there as the tension. So every time you rotate, you're rotating your rope or the string or the pendulum bob, know that there is a force that is acting towards the center, which is the tension. So this tension gives rise to centripetal force. So we have another force which is known as now the centripetal force here. So if we have the centripetal force, as you're rotating it, what happens? You see that when it reaches some points, there is the weight also acting on this and the bob, because the weight will be pulling it down and the tension is pulling it to the center, and yet it wants to rotate, moves across the circumference. So that one gives us the weight. The weight of this body, for it acts downwards. So you find out that when it reaches some points, that weight is neglected. There is also another force still acting on it. This way here, there is a force that goes outwards. So what is this force that goes that side? This force here is known as the centrifugal force. We have it as the centrifugal force. For this centrifugal force, what happens is that it does not act towards the center. For it acts outwards. You see, this is our bob. It takes the opposite direction to the tension. So it is now the tension here that balances this centrifugal force so that it keeps the body rotating in a circular manner. So those are some of the forces that are acting on a body when it is describing a circular motion. So how do you find this circular motion? Where do you find examples of this circular motion? In real life, there are very many, though sometimes we tend to neglect them. For example, when a car is moving, taking a curved path, what happens? There is the tire of this vehicle is going to experience these forces here. It will be experiencing the weight. It will be having the tension pulling the tire. So if you find all these forces acting on it there, that means that it is describing a circular motion. We also have the satellite, the artificial satellite. So when it is trying to orbit around the Earth's surface, what happens is that it goes round in a circular motion. So you find all these forces also acting on those artificial satellites that have been released to the space. So we also have, you can have a simple one, which is the pendulum bob, where you can tie a string. You have a string, then to the end of that string, you tie some mass on it. It can be anything. It can be a bob or it can be a stone, and then you try swinging it. You see that it will be rotating at a fixed point. So you find also all these forces acting on that stone you're trying to swing around. So those are some examples of this circular motion. So with this, we come to the end of our lesson for today. We shall meet again in the next lesson.